Point A, a 90-degree rotation. Let's do number 1 first. Number 1 was Albert. Did you already type? I can't see. What'd you get for number 1, Albert? So first of all, you might want to count how many points there are and divide it into 360. So how many points do we have? 1, 2, 3, 4, 5, 6, 7, 8. So you might want to do 360 divided by 8. We did that a little bit yesterday. So each time you're moving from point to point, you're going 45 degrees. So we want to be at point A, and we want to do a 90-degree rotation. The problem is they didn't tell us which way to go. And remember, when we're not on the coordinate plane, we can go clockwise or counterclockwise. So really, number 1 has 2 answers because they didn't tell us which way to go. So let's go ahead and put both of those answers. Okay, good. So to go 90 degrees, we'd have to go 45 and then 45. So 45 and 45, so G, and then 45 and 45, or C, because they didn't specify. When I say they, I mean me, because I think I made this one up. I didn't specify which way to go. Okay, so next one. Yay, G, sorry, type it in again. What'd you get? Next one. 180-degree rotation. Okay, so we're going to look for the one pretty much on the other side of the figure, right? So point H, we want the one on the other side of the figure, because 180 degrees is halfway. It means you're going halfway around. So D would be the answer. You can also think of it as what is 180 divided by 45? It's 4. So you need to jump 4 spots. 1, 2, 3, 4. You were answering for point A. I gotcha. Hey, y'all need to plug in your cameras. I know we haven't done it in a while. Go ahead and plug in your cameras so I can see you. Okay, who was number 3? Jenny? Can you write number 3 now? Thank you, guys. Oopsie. Okay, AB, a reflection in AE. Okay, so this is what people have trouble with sometimes. So we want AB, and we want to reflect it over AE. This one's not too hard because it's touching that line. So if we take that point and we reflect it over, this would be our image. Okay, very good. All right, and the last one was Austin. GH, a reflection in AE. So, same line of reflection, but now we want to reflect GH. And be careful because a lot of people answer CD. But the answer is not CD. That is a really common mistake, so that's why this warm-up is really important. What is the answer? Oh, yay, G, you're supposed to let Austin correct it. Okay. Yes, the answer is CB. Because if you were to fold the figure on this line, if you were to fold it on this line, think about where GH would end up. That's where you crease it. You crease it on the line of reflection. And so you're pretty much saying, how far away is this from my line of reflection? And you want to go the same amount this way. You want it to be a mirror image. You want to find the mirror image. It's a reflection, a mirror. So the answer to number 4 is BC. Moving on. Here are the answers to your rotations worksheet. Let me know if you have a question about any of those. It's really hard to see that, isn't it? Let's zoom in. Can you see it? Those points are so tiny. You want me to go over number 10? Pretty much 1, 2, 3, and 4 are just, can you find the points and can you use the rule, right? 3 and 4 we really didn't talk a whole lot about, but you just needed to find points and use the rule. We're not really going to be rotating on the coordinate plane very much. I mean, I didn't mean on the coordinate plane. We're not going to be rotating equations of lines very much. There's what 5 and 6 look like. Number 8. Is there a number 10? Number 10? Oh, okay. Do I have another slide? Yeah, okay, sorry. Number 8, you can write that as a decimal, or you can keep it as the exact number. You could have written it as a fraction. 3/67. Okay. Number 5. You're asking about number 5? Like I said, we're not going to do a whole lot of equations, like linear or quadratic equations, rotating them, but all you need to do is take A, B, and C and apply the rule. That's all you had to do. So the rule for 180 is -x, -y. So you're really just taking these numbers and you're making them negative. So in that case, 180 degrees counterclockwise rotation is really a reflection over the x-axis in the case of that parabola, because parabolas are symmetrical. Okay. No, equations of lines won't be on your quiz. Not equations of lines. Rotations, yes. Number 10, you're just doing 360 divided by 5. Yeah, that last point of the pinwheel was really light. It was hard to see. Number 9, let me ask some additional questions about number 9. If point B was reflected over AC, what would be the result? Kind of like the warm-up. I'm just making sure we got this. B is reflected over AC. Good, so the answer is not D, right? The answer is not D. The answer would be X. Okay. Moving on. We're not going to do a dilations experiment, but this is our last lesson, like I said, and you can title your notes Dilations. Dilations. This is our only transformation where we're actually going to change the size of the shape. This is different. All the other transformations were congruence transformations. This is the only one that is not a congruence transformation. We're going to enlarge or reduce, and it's definitely going to be proportional to the original. And we'll dive much, much deeper into this after the winter break. Now, all the other shapes produce congruent figures. All the other ones produce congruent figures. But a dilation produces similar figures. And the symbol is just a squiggly. It's not an equal sign with a squiggly over it. It's just a squiggly, or like a tilde, right? So dilations produce similar figures, whereas all the other ones, translations, rotations, reflections, they all produce congruent figures. Dilations produce similar figures. Huge, huge point right here. Angles will remain the same in a dilation. Angles will remain the same because it's proportional. That's why. And there, just for fun, is a picture of dilated eyes. In dim light, your pupil gets larger, and then if you were to turn the lights on, you would see your pupil shrink again. Dilations. Okay, resize. A dilation is a resize. Okay, when we dilate, we're always going to have a scale factor because it's always going to be proportional, and it's going to tell us about the size change. You probably already know this. You don't need to write this word for word. But if the scale factor is greater than 1, it's an enlargement. If the scale factor is less than 1, it's a reduction. And if it is 1, it's a congruence transformation. So when we do translations, reflections, and rotations, it's called a congruence transformation because we're not changing the size. Greater than 1 enlargement, less than 1 reduction. Okay? Okay. I know, it's ridiculously easy. It's silly. So what happened? How do we know which one is the image and which one's the pre-image? You didn't miss a whole lot, Helaman, but you can, I'm recording so you can watch it if you need to. Yeah, so the prime tells us that that is definitely the image. Is this an enlargement or a reduction? Definitely a reduction, okay. And so what would the scale factor be? What is the scale factor that gets us from the pre-image to the image? Good, you didn't say 2. It's not 2. Okay, so 2 would mean that our shape doubled in size, but our shape is half as big. So the scale factor is 1/2. Now how do we get the scale factor? How do we use the number 5 and the number 10 to come up with 1/2? We put 5 over 10, and that reduces to 1/2. So to get our scale factor, we're going to put the second figure over the first figure. Second over first. We're actually dividing. To get our scale factor, we're dividing the second divided by the first. So I would write that down somewhere. Scale factor is second over first. Second over first, second over first, second over first. Okay? So what if I give you a diameter and I give you a scale factor? Could you find the diameter of the image? Now is when you multiply. So you take your diameter, you multiply it by your scale factor, and that's going to get you your new diameter. If you're looking for the scale factor, you're going to make a fraction. If you have the scale factor and you want to use it, you're going to multiply. So, okay, 8 divided by 2 is 4, 4 times 3 is 12, very good. So this sun would have a diameter of 12. Okay, enlargement or reduction? Enlargement. So I need you to find the scale factor, and Adriana, this one's yours. Adriana, when you're ready. It is going to be a fraction. No, it's not. Sorry, it's perfect. There you go. So the way we come up with our scale factor is we put the second over the first, and that means that that red hexagon is 13 times bigger than the gold one. 13 times bigger. I don't think it's drawn to scale, but We can use our imagination, okay? So you do the second divided by the first, and that will get you the scale factor. So if you wanted to check your answer, you would do 8 times 13, and you should get 104. All right, let's just look at these. Is it an enlargement, a reduction, or a congruence transformation? Number 1. Enlargement. Number 2. Reduction. Number 3. Enlargement. Number 4. Congruence. Number 5. Enlargement. So just because it's a fraction doesn't mean it's a reduction. If that fraction is greater than 1, it's an enlargement. Ears. We spelled ers. Ears. Okay. Helaman, are you ready to be put on the spot? Your card's up. Can you tell me what the scale factor is for these shapes? Very good, very good. Not 3/2, but 2/3. And if you forget which one you're supposed to put above and below, which one's the numerator and which one's the denominator, all you have to do is ask yourself, is this an enlargement or a reduction? And you would say, oh, that's definitely a reduction. So then you check yourself, my scale factor better be less than 1. So if you accidentally think, ooh, I don't know if it's 2/3 or 3/2, you would know, oh, it's definitely 2/3 because that shape has got to get smaller. Okay? Smaller. Oh. Question marks? Okay. So, when you're on the coordinate plane, you want to find sides of your figure that are either horizontal or vertical. You never count diagonally on the coordinate plane. Never count diagonally on the coordinate plane. So you can use AC and A prime C prime, or you can use BA and B prime A prime. So you can do 2/3, or you can do 4/6, but you would have to reduce the 4/6, obviously, if you chose to do the vertical lines. Okay? Next one, Taha, you're up. There's 2 people absent. Do y'all know who's absent? Oh, Carson again. Okay. 1/3, okay. Second over first. 1, 2, 3, 4, 5, 6. 1, 2. So be careful. You have to pay attention to the primes and the non-primes. That is an enlargement. It's an enlargement. So our scale factor better be bigger than 1. You put the second over the first. You put the prime over the non-prime. And so it will be 3. Okay, so just make sure if it's an enlargement that your scale factor is greater than 1. Hussein and Carson. Okay, thank you. Next one, George. This one's yours. Yeah, 1/2, right. So the second one was 4, and the first one was 8, and so that reduces to 1/2. This was 8, this was 4. Half is big. Brandon, this one's yours. You got to use RT because you can't count SR and you can't count ST. So you got to use RT. If you needed help counting, it's hard to count on those little squares. Okay, so second over first. Second over first, and then reduce that. Am I not being clear about the second over first thing? Is that confusing us? The prime over the non-prime. Okay, you didn't see the little tick marks, the little primes? So 5 halves. It is an enlargement, so your answer's got to be greater than 1. Okay, Kwan Lee, you do A. Minjung, you do B. Tahani, do C. Albert, do D. And we'll all do E. No, enlargement can't be your answer to scale factor. Scale factor is to be a number, please. A number. Good? Me and Jamie up. Well, you already know it's 9. So yeah, you're doing 9 divided by 3. Second over first. So the answer is 3. No. No. Okay, so how scale factors work. If you're going forward, you multiply by 3. If you're going from here to here, you multiply by 3 because 3 is our scale factor. If you're going backwards, you want to divide by the scale factor. So if you're going from here to here, you're dividing by 3. So A prime C prime is 10.8. I want to go, I want to go backwards. I want to get smaller, right? I want to get smaller. So you're going to do 10.8 divided by our scale factor. We're dividing because we're going backwards and because we want to get smaller. Okay, good. And then Albert, what's one of the things we wrote in our notes at the very beginning? What's one of the things we wrote about the angles? Yeah, the angles do not change. The angles do not change. The angles do not change. They don't get larger, okay, because their figures are similar. So the angles don't change, so it's 50, and that is similar. Moving on. Oh, we're done. Yay!